It's Thomas the Tank Engine. Fascinating. Just designed, I'm sure, to be hacked. Brilliant little things. But the problem is there's two different styles of track. So if I look at this, which I believe is Tommy track, can we see that there? Tommy. If I try to run a normal Thomas over it, I find it sticks. But if I modify Thomas and take the bottom out, just what I've done is just very crudely grind off the bottom bit here, and then that seems to get over the Tommy track. The other type of track I've got is this, which seems to be made at different times by different people. So if we look there, we've got Mattel 2009, and over here we've got what looks an identical piece of track, but is the HIT toy company. They look very similar apart from the mechanism for changing the points. This looks a lot better quality, as it has a nice metal rivet in the bottom, as opposed to this 2009 where it's just a lump of plastic. I suppose it makes it cheaper to produce, and well, I assume they think it'll work just as well. So what have I done? Well, Thomas the Tank Engine is great, but as supplied can only go in one direction. So if we set him going, he goes that way. Yeah, brilliant. But I can't reverse him. So what I've done is to add a switch to the top, so that when I flick it forward, Thomas goes backwards, and when I switch it backwards, Thomas goes forwards. Probably the wrong way round, but I'd have to change it over on the motor to get it to work the right way. These Thomases, incidentally, are what? Can I see that? Yeah. Oh, upside down. Gulland. This one then is also Gulland 2013. Gulland 2013. Gulland 2013. But on the bottom here it says Mattel 2013. So these are the ones that I'm going to hack. I've got other Thomases, like this one here, which, if we look at it, is a different Thomas. It says Brit Allcroft, and at the other end it says Tommy, made in Thailand. Now this isn't as hackable as the other Thomases, well, the other trains. Should have a C cell in there, but it's just the same size as an AA. But it has a very complicated gearbox. It's a beautiful little gearbox, and what happens is the wheels are free to spin until you switch it on, when you have to press it all the way across for them to go round. So halfway we switch the motor on, but it hasn't connected the wheels, and we can switch it off. Very difficult then to hack, but a beautiful little gearbox. I have another one here which is even more beautiful in its design, but that once again difficult to hack, and it's only using the one battery. It also has on the bottom a click switch, so that if it is switched on, famous last words, oh no, I can't switch that one on, it's broken, solder seen, but this one, take the battery out, switch it on, and it should have a click switch in there, or a quick click clutch, so you can turn the wheels without damaging the battery. So how have I done it? Well, if we look at a sort of standard Thomas, or perhaps we don't, because I'd have to take it all apart and can't be bothered. So let's look at the one I've modified. This one that I've modified then, as I say, it's got a switch on the top. Now, the type of switch is a 3-position switch. This is a toggle switch, so it goes forwards, off and back. But I haven't used one of those. This is probably a second-hand one. Well, it is a second-hand one, it's got it out of something, but I didn't want to damage Thomas, so I used a slide switch. So here we have a normal slide switch, which would have 3 contacts on the bottom, 3 contacts in line, just one set of 3. But to reverse it, we need a different type. We need a switch that has got 2 sets of contacts, and in this case, unfortunately, it's got a couple of extra ones that I don't need. That's this one here and that one there, so I just need the 2 outside ones and the 2 middle ones. If we look at the manufacturer's, or a manufacturer's data sheet, then we can see that we have 8 switches. There's 2 in the middle that are called common, and 2 at each end. So when it's in position 1, in other words it's slid to that end, 1 and 3 are connected together, and 7 and 5 connect together. In the middle we've got 3 and 2, but we're not using 2, so we're not bothered about that, and we're not using 6, so we're not bothered about that. Then at this end 3 and 4 connect together, so when it's at this end we've got 3 and 4 connected, and 7 and 8. So they are how it works. These 2 are completely separated but must move at the same time. The original Thomas is, I like it, I love the design. Essentially what we've got let's move Thomas out of the way. Bye Thomas. What we've got is 2 cells, so we have, let's try doing a bit of colour, I don't know which way around it is, but we have our cells connected like so. So we have a negative and a positive. Now, to make the construction very simple, what they've done is to connect the motor across this end between the 2 cells, and at this end they've just used 2 pieces of metal to form what seems to me to be a very effective but crude switch. So as soon as the switch is connected, the current flows round through the motor and round this way. They haven't bothered connecting these 2 together as is normally done, as this makes it a lot easier construction. So what do I want to do? Well, my idea then is, with the cells, I connect them together to make them into the usual 3 volts and come out at this end. I then have my switch. I'll just draw the connections I'm going to use and not the 2 that I didn't. Positive can then go into there and negative can go into there. Maybe making that a different colour will make it easier to understand. I then just take my motor from this end here. So as it's drawn there, if I slide my switch this way, the positive will go through the switch, round through the motor, back to here, back through there, back through the negative and back to there. So it only goes in one direction. So I want to be cunning and make it go in the opposite direction. So I take this connector and connect it to there. And I'll use a different colour, hopefully to make it easier to see. I can use that one and connect it to there. Now what happens? When I slide the switch this way, we've already looked at it, the top becomes positive. But when I slide the switch the opposite way, this blue wire becomes positive and that connects to the bottom of the motor. So the current goes the opposite way through the motor. So it goes in the opposite direction. So let's have a look at Thomas himself to see what I've done. So the problem with Thomas's, one of the first problems anyway, if we take the top off, how do we take the top off? Not with that. Put this in here. It has a posi screwdriver. Have I got that? I don't think I've got that. Maybe I have got it. Oh yes, I've got it easily. So the top comes off like so, but the bottom has a triangular screw in it. Don't know if we can see that or not there. So it's triangular is the head of the screw. So what I've done is just take a piece of 3mm rod and grind it down. Unfortunately on this one I've ground it a bit far and it's actually twisted as I've tried to undo one of these screws. The other end is more or less okay. So that then fits into there, or it would do if I could see it. Let's go back down in size. I've also made an adapter. I'm sure you can buy these things, but I haven't seen them. And anyway, it's just as easy to grind it. So let's take that out, hopefully. So that's taking the screw out. Let's put it in a safe place and open up. Well, let's open up the top for a start. So if we can see in at the top, must be a focus somewhere. There, we've got a focus. We can see that I haven't used these 2 intermediate pins. I've just used the 2 at the end. I've taken the power into the 2 middle contacts, so I've got red at the top, there's black at the bottom which you can't see, and then I've crossed them over so this pink purple wire goes to the connection at the back, and this I've just used a piece of normal wire to the connection at the back here. So those are the 2 crossovers as I did in the diagram. And then very crudely I've glued my switch in so that it sticks up at the top, and I haven't had to modify Thomas at all. to get the switch on. Maybe it'd have been better with the toggle switch, easier to see and use, but that means I haven't damaged Thomas at all. If we look then at the other part, I've taken the two wires to the motor through the slot where the switch used to come, and hopefully I can just pull this apart, take it out. We can see that all this has is a worm gear onto the pinion on the output wheels. Interesting to note that the pinion on the output wheels also has a sort of dog clutch, so that if somebody tries to run it along, then the dog clutch will operate, and we can see that will move, open and close. Bit worrying that, because it is only designed to operate one way. I've had no trouble with that yet, running in reverse, but it could be a problem. Anyway, so the motor itself then is just held in. If I just gently slide it out, we can see that the wires come underneath. I've just taped them up because I haven't even bothered soldering them onto the motor. I've just twisted them round, because what would have happened is here the battery itself feeds down through these two connectors, and they just touch against the motor, so there's no need at all for any soldering. They two contacts there just touch against the motor by compression once the motor's pushed in there. What I've also had to do though is to join this end of the cells together to make it into a battery, so that I've got positive out here going to my switch and negative coming out here, as I did on my diagram, which hopefully we can see. So I've connected the two ends of the batteries of the cells together to make a battery. Those two ends then go to the centre contacts on the switch, which is on the top of Thomas, and then they've got crossover wires, and then they come back down to the motor. All in all, a very nice project, but you do have to pick him up to switch him on and off, and maybe the next one will be some other method rather than a switch on the top to switch him on and off, or to make him change direction. An interesting project. There's just so much hacking to be done on Thomas. I'm going to have great fun with him. Right, that's it for now then. Yeah. Bye now. Bye.